Okay. Good evening to everyone. In last class, we discussed the topics of solid modeling methods like modeling methods in CAD/CAM. They are wireframe modeling, surface modeling, and solid modeling. Next, entities of surfaces like analytical and synthetic surfaces. Today in this class, we will discuss about solid modeling techniques, namely constructive solid geometry and boundary representation. Okay. Okay, we are presenting a presentation on CAD/CAM subject in Unit 2, which is geometric modeling. Previously, we discussed about geometric modeling methods like wireframe, surface, solid. Okay. Advantages of various modeling methods like wireframe, surface, solid modelings. Today in this class, I'm discussing solid modeling techniques. Okay, I will show you in my PPT. These are all the topics we completed in previous class. Coming to today, okay, constructive solid geometry. It is the one modeling technique of solid modeling methods. Okay, methods are solid modeling techniques. Coming to CSG, CSG is full abbreviation of CSG is nothing but constructive solid geometry. CSG defines a model in terms of combining basic and generated solid shapes. In last class, we discussed about solid primitives like block, cylinder, cone, torus, etc. Here we are using extrusion and sweeping operations. Sweeping is nothing but, first of all, we are taking a planar curve. After translating, revolving the planar curve and prepare a solid model, etc. Okay. Next, objects are represented as a combination of simpler solid objectives. Recently, I told to you, primitives like shapes are rapid prototypes of solid techniques like cone, cylinder, etc. Here, CSG, constructive solid geometry, uses Boolean. In comparing with constructive solid geometry with boundary representation, in CSG we are using Boolean operations. Coming to boundary representation, we are using Euler operations. So, okay, first of all, I'm discussing about constructive solid geometry. In constructive solid geometry, Boolean operations like union, subtraction, and intersection. We already know that union is nothing but uniting or joining. Here, which one is joining? That means here we are joining like two volumes. First of all, Here I am discussing about volumes based on volume. Combining of two volumes included in that different solids into single solid. Operations like joining of two volumes and converting into single solid. Next, coming to subtraction. Subtraction is nothing but removing object. Here, which one is removing? That means which one is cutting, like the operation subtracts the volume. Here also I'm telling that based on volume. One solid from other solid object. That means here I'm cutting or subtracting one solid from other solid object. Coming to intersection. We already know that intersection is, that means similar objects or similar parts will be joined. The operation keeps only volume common to both solids. That means similarity between two solids, joining only. That means keeping only volume here. Next, here I am showing that Boolean operations. That means union, subtraction, intersection. First of all, let's see all of you. Union. Union means here first one is the, I'm denoting first one is A, denoted by capital A, and second one is the capital B, two solids. So I'm joining in middle section, I'm joining two volumes. In middle section, I'm joining one rectangular plate with circular or cylinder. That means A is a rectangular plate, B is the circular or cylinder. Okay, A is joining with cylinder. This process is, that means this operation is known as union. Next, coming to subtraction. Subtraction, here I am showing the process of subtraction. A is a rectangular plate, similar plate is taken for explaining the Boolean operation of subtraction process. A is a rectangular plate, B is also a cylinder. Here I am removing the material from cylinder. That means B is the cylinder, A is rectangular plate. For joining two materials, I'm subtracting B minus A. That means I'm subtracting the or cutting the material from cylinder and joining the rectangular plate with cylinder. B minus A is the subtraction process. Next, coming to intersection. Intersection means, in previous I told you, intersection is nothing but joining. That means keeping only the volume, keeps only the volume similar to both surfaces or similar to both. Here A is rectangular plate, B is. That means intersection means removing material in rectangular plate similar to cylinder. That means joining two, the rectangular plate with cylinder, keeping only the volume. I'm not discussing about any surfaces like anything. I'm discussing with only based on volume. These are the Boolean operations performed in constructive solid geometry. Next, solid modeling examples using CSG. Plan your modeling strategy before you start creating a solid model. Here I am taking a solid model. This will be prepared or this will be generated by following the operations, Boolean operations like union, subtraction, after that intersection. First of all, for preparing this type of geometrical model or solid model, first of all I am taking a cut section of cylinder and one rectangular plate, taking two different shapes or two different primitives. After that, using of operation like union. After using of union operation, these two will be joined, and then I am using cutting or subtraction operation for making a hole. And next, again I'm generating cutting operation, generating or using subtraction operation here for removing material in this area. After that, using of two operations like union, cutting, and after cutting, this solid or this geometric model will be prepared. Next, CSG data structure. Data structure does not define model shape explicitly, but rather than implies the geometric shape through a procedural description. That means in this statement, I'm discussing about data structure is not define any model shape. Okay, it define only shape through a procedural description. That means data structure discussing about only description, not a model shape. For example, object is not defined by a set of edges and faces, but by the instruction. That means here in this data structure, we are discussing about procedural description. That means this procedural data is stored in a data structure. That means these complete instructions to be stored in data structure refer to a CSG tree. CSG tree consists of faces, edges, vertices in a order. Okay, this is the CSG tree. For basic, or for example, I am taking first one, the middle, first one, the top one is the faces, and and next it consists of edges and vertices. CSG tree stores the history of applying Boolean operations on the primitives. Primitives. Previously, I was told you primitives like cylinder, cone, block, cube, etc. Torus, etc. Here, the complete history will be stored in CSG tree, including of all Boolean operations. Stores in a binary tree format, the outer leaf nodes of tree represent the primitives. That means in this slide we are discuss about CSG tree. The basic instructions or the history of applying Boolean operations are stored in a CSG tree in a tree format, binary tree format. Next, advantages using constructive solid geometry. CSG is a powerful tool with high level command. Next, easy to construct a solid model, minimum step. Okay, easy to construct a solid model, very easy model in solid modeling techniques. Here in this, complete history of model is retained and can be altered at any point. That means the history of model is nothing but here we are using Boolean operations like union, subtraction, intersection of all obtaining, generating the geometric model. The history will be stored in data structure. At any point, we can modify the geometric model. Next, can be converted to the corresponding boundary representation. CSG can be easily converted into corresponding boundary representation. Boundary representation, it will be discussed in later. Next slide. Next, CSG. Up to now, we are discussing only advantages of constructive solid geometry. In this slide, we are discussing about disadvantages using constructive solid geometry. Only by using Boolean operations are not allowed in the modeling process. That means by using Boolean operations alone, range of shapes to be modeled severely. That means unusual shapes are not possible to construct. Requires the information of boundary, faces, edges, which is important for the interactive display. The main disadvantages by using constructive solid geometry, not possible to construct unusual shapes. Only usual shapes will be prepared by using constructive solid geometry because of CSG tree. Next, coming to boundary representation. Boundary representation, solid model is defined by their enclosing surfaces. Or here we are discussing about based on surfaces or boundaries. Okay, it consists of the geometric information about faces, edges, vertices of an object with topological data. Topological means topological is nothing but length, breadth, width, etc. height. Topological, remember that topological data is nothing but length, width, breadth, height. B-Rep model is created using Euler operation. Previously, I was told you in CSG we are using Boolean operations: union, subtraction, intersection. Coming to boundary representation, we are using Euler operations. Euler operations is nothing but we are using the data. We are using the data which is related to faces, edges, vertices, and based on topological data. Here, similar to data structure, we use it in constructive solid geometry. Here also we are using data structure like B-Rep graph store faces, edges, vertices as nodes with pointers or branches between the nodes to indicate the connectivity. Connectivity means first of all we are creating faces, after then edges, and finally vertices. This is the branches generation process. Next, first of all, combinational structure topology metric information. First of all, I am taking a solid. This will be generated by using the information of based on topological data with the information of geometrical model data of faces, edges, vertices. Okay, I am taking a solid model here. This will be generated by using face table, edge table, vertex table. Coming to face F1. First face F1. F1 consists of edges like E1, E5, E6. Here I am showing F1 will be the face. It is generated by using edges like F1, edge table consists of edges and vertices. For coming to even edge, it consists of vertices like V1 and V2. Edge E1 is generated by using vertices V1 and V2. Similarly, E2, E3, E4, E5, E6, E7, E8. Coming to vertices table, V1 is the vertex. Okay, here I am showing the vertex. Vertex is generated by using coordinate points X, Y, Z axes X1, Y1, Z1. For V2 vertex X2, Y2, Z2. This is the procedure for boundary representation data structure. Operations performed. Operations means here we are using sweeping and extrusion process. First of all, I am discussing about a sketched feature. I am taking a 2D sketch, creating a feature from the sketch by using extruding, revolving, sweeping operations. Here I am showing first figure is the revolved feature liner. It is the liner. Second one is the extruded feature. Extrusion means blending operation. Sweeping. Sweeping consists of linear extrusion or non-linear extrusion. First of all, sweep a cross section along a guided curve. First of all, we are taking a guided curve. Guided curve will be sweeping along a cross-sectional curve. Blending. Blend a two cross-sectional section linearly. Linearly means without bending, including without any bending. Sweep two cross-section. First of all, remember that first of all take a single guided curve and apply sweeping operation. Next, take two cross-sectional curves and apply blending operation. After that, applying blending operation, taking two cross-sectional curve, again apply sweeping operation, and next finally loft to blend two cross sections. This will be the sweeping process. Next, sweeping is nothing but it is a modeling function in which a planar closed domain, that means a planar curve, will be translated or revolved to form a solid. In sweeping operation, we are taking a planar curve and it can be translated or revolved to form a solid. When the planar domain is translated, the modeling activity is called translational sweeping. When the planar region is revolved, it is called swinging or rotational sweeping. That means, first of all, it is translated. Translated means transferring. First of all, in sweeping operation, two types of classifications are there. Planar curve will be translated. It will be called as translational sweeping. That will be in a linear direction only. In planar curve, it is revolved. Then it is called swinging or rotational sweeping. First of all, here I am showing, first figure is the translational sweeping. That means in linear direction. After that, I am applying translation of revolving operation. It will be called as rotational sweeping. These are the two figures for translational sweeping and rotational sweeping. After that, creating features from sketches. First of all, I am taking L section. Here I am showing the operations by applying like sweeping, blending, revolving, extrusion process on L section. For example, I am taking L section. By applying sweeping operation, I can prepare this type of model. By applying revolving process, this type of model can be prepared. These are the some models. Boundary representation. Coming to advantages by using boundary representation, capability to construct unusual shapes. Remember that in constructive solid geometry, the main disadvantages included in CSG is that not too possible to construct the unusual shapes. Okay, here coming to boundary representation, it is the main advantage. Here we are used to construct unusual shapes, not to be possible with available of CSG. That means in CSG not possible to construct unusual shapes. In boundary representation, easy to construct unusual shapes. Less computational time to reconstruct the image. In CSG, very high computational time is taken to construct the image. Coming to disadvantages, requires more storage. In CSG, it taking less compatible storage. Here in boundary representation, it takes more storage. Next, complex curve and surfaces only approximated. It is the disadvantage of boundary representation. Next, advantages and disadvantages over solid modeling techniques. Then wireframe and surface modeling techniques or geometric modeling methods. Coming to advantages of solid modeling techniques, allows the designer to create multiple options for a design. That means easy to construct or easy to create. The multiple options a designer to create a model. Next, 2D standard drawings, assembly drawings, and form the 3D model. Here we can use 2D or assembly or explore to generate 3D models. Next, can easily be exported to different finite element methods programs for analysis. Modeling in this solid modeling parts or solid modeling models. That means models can be easily exported to finite element methods programs for analysis. Mass and volumetric properties of an object can be easily obtained. That means total mass, mass center, area, and mass moment of inertia. Main advantages by using solid modeling is nothing but here we can use 2D assembly exploded views to create 3D models. Easily to export for doing analysis of finite element methods on models. Next, coming to disadvantages. More intensive computation than wireframe and surface modeling. Here, computation is very much computation is required than wireframe and surface modeling. This is the main advantage than wireframe and surface requires more powerful of computers, faster with more memory and good graphics. Why? Because of faster computer, powerful computer or more memory and good graphics are required in solid modeling because of for faster computer. That means powerful computers are required to move on process. Why? Because here we are using more powerful softwares to generate solid models. That means here we are using for solid modeling techniques, we are using powerful softwares. To run powerful softwares, more graphics. That means RAM is more RAM is required with graphic card to display fast graphics operations. These are the disadvantages of solid modeling. In next class, we'll discuss about representation of curves. Okay. In this class, we discuss about solid modeling techniques of constructive solid geometry, advantages, disadvantages of CSG. Next, coming to second one is the boundary representation. Boundary representation advantages and disadvantages. Next, coming to main advantages, disadvantages using solid modeling methods. Okay, this is the very important topic of solid modeling techniques.